Have you ever wondered how smart watches and the medical devices measure your heart rate and the blood oxygen level? Today, we will build an Arduino-based heart rate and SpO₂ monitoring system using the MAX30102 sensor to monitor the vital health parameters in the real time. Welcome to RoboXCraft, crafting imagination into reality. At RoboXCraft, we help students learn robotics, IoT, and automation through hands-on project kits designed for real-world learning. This project uses MAX30120 sensor to measure heart rate and the blood oxygen saturation, commonly known as SpO₂. The sensor detects changes in the blood flow through your fingerprint and display the readings on the LCD screen. This project is ideal for school or college projects, science exhibitions, engineering mini projects, robotics learning, and Arduino beginners.
Hi everyone, today we are going to make a heart rate monitoring system project by RoboXCraft kits. So let's explore what comes inside these project kits. First of all, we have a battery holder with 186502 batteries with a LCD display. Also, we have used a microcontroller Arduino Nano. This microcontroller is compact and way better than Arduino Uno. Next, we have SpO₂ MAX30100 heart rate monitoring sensors. Also, we have a breadboard to connect all those wirings and Arduino Nano in this board only. Also, we have jumper wire and switch. So now let's start with making the project. Let's start with the circuit diagrams and connections of the components. First of all, we will be going to take a breadboard. Also, we are going to integrate this Arduino Nano in this breadboard only. Make sure to keep this Arduino Nano that output port this side. Now we will be connecting this MAX30100 sensors, heart rate sensors, to one of the side in breadboard. After that, we will be connecting this heart rate sensors to Arduino Nano. Also, we are going to connect one LCD display to this project to display the heart rate and SpO₂ data. Now we are connecting this the positive of heart rate monitoring system positive to 5 volt of Arduino Nano. After that, we are connecting this GND, this last one pin, to VCC GND of Arduino Nano. After that, we will be connecting SDA to A4, SDA of heart rate monitoring system, SDA to A4 of Arduino Nano. After that, we will be connecting that SCL to A5 of Arduino Nano. Now we will be adding this LED display to this project, where it comes with GND, VCC, SDA and SCL, same like this heart rate monitoring system. So we will be adding this LED display connections, same like in the heart rate monitoring systems, where we will be connecting 4 jumper wires. After that, we will be connecting that GND again to GND of Arduino Nano. Next one is VCC. We will be connecting VCC to 5 volt of Arduino Nano. After that we will be connecting SDA. Now we are connecting SDA to A4 of Arduino Nano. After that SDA SCL of LED display to A5 of Arduino Nano. That's it. This is the circuit diagram. Now we will be adding the code to this Arduino Nano. Before adding the code, make sure to download the correct library files and follow the method of adding the codes in this project. After that we are using a Arduino Nano cable to connect Arduino Nano to our laptop. After uploading the code successfully, we will be adding a battery, switch and a battery holder to our project, where we will be connecting the positive of battery to VIN of Arduino Nano. Also the negative of battery to GND ground of Arduino Nano, and click on the switch. Now everything works fine, the battery is connected, the codes are already uploaded. Now we'll be testing the heart rate sensor. So for now, without placing your fingers in the sensor, the reading is up to 300 to 400. After placing your finger on the sensors, the reading will be from 6000 to 8000. So now we are getting the reading of 7300 approx, 73,000. So this means the expected output meets the code, and this project is working successfully.